Welcome, listeners. So again, we have gathered here to discuss on the next topic, that is volcanic activity, in the series of lectures on fundamentals of geology. So here we'll start our discussion on the volcanic activity and related volcanism. The understanding of volcanic activity and related volcanism is very essential because obviously, if I think about the origin of all the rocks, then like we have mentioned earlier, the first rock possibly to form was obviously igneous in nature, and that igneous rock, like we discussed in the idea of your origin of the solar system, or the idea of continental drift and plate tectonics, the initial igneous rocks that were formed, be it on the land or on the ocean floor, they were strictly a result of some kind of volcanism. So the understanding of volcanic activity is essential in that term, as well as it is also essential because volcanism, these are the kind of tectonic features that directly have an impact on the human lives and livelihood. So an understanding of that how volcanoes work is essential to the fundamental understanding of geology as a subject, as well as the understanding of how it might erupt at certain point of time or not will have a direct impact on the lives and livelihood of thousands, lakhs, or sometimes millions of people. So a volcano, to start with, to define a volcano, it is a geological feature obviously on the earth's surface, typically a conical hill or mountain through which molten rock as gases erupt onto the surface of the earth, or gets mixed in the gases will get mixed in the atmosphere. Volcanoes are natural vents in the earth crust that allow magma, gases, and volcanic ash to escape from beneath the surface. So, if I now look at a volcano in a cross section like this, then I can look at the various components of a volcano, starting with, obviously, if I am referring to volcanic activity, it has to be related with some kind of magma chamber or molten material that is sitting deep beneath the earth. So, if I start with this component, that is the magma chamber, from which your rest of the molten mass, your magma containing large amount of water, volatiles in it, will be derived from the magma chamber. Finally, when it reaches a certain buoyancy, the magma that is present in, will be also talking about how it gets erupted, and in which cases it might get erupted, in which cases it will not get erupted, will in a bit later on. But if due to the changes in the buoyancy, this magma that is already present in the magma chamber makes up to the surface of the earth, then obviously it will form a crater first, through which your both solid, liquid, and gaseous materials that were component of the molten magma that was present in the magma chamber will be erupted onto the surface of the earth. So talking about different components, so this is the first thing, that is a geomorphic feature as well, that it will develop conical hills on the surface of the earth. So that is the cone of the volcano, and it will also have a vent that is connected directly to the deep within the earth. It is connected directly to the magma chamber. So you will also have a crater that obviously will sit at the top of the conical shape of the, or the cone of the volcano. Then surrounded by, obviously, if there are outpouring of molten material through this vent, then this cone will be mainly made up of various phases, or you can say various episodes of molten rocks that has erupted on the surface of the earth. So there are these different episodes of solidified lava layer, followed by some events of, you can say, normal sedimentation, then again some events of lava eruption, again normal sedimentation. So there the cone will grow with time, be it a gentler cone, be it a steeper cone, we will talk about that, but this cone or this conical hill will grow in size over the time. So you have a main chimney through which will be finally or which will finally result into the formation of a crater, or that is the main vent. So that is your main chimney. Then you can also have some secondary cones or some secondary vents which are related to the original or the main chimney. Then obviously you can have some other structures or geomorphic features as well, like fumaroles and geysers. We will be discussing about that later on. So here whenever some volcanism is taking place at a crater, then it will also erupt along with the molten magma that will be, now we'll call it a lava because it has surfaced the earth. So when it will finally surface the earth as lava, so what will happen, the volatiles that are present in the molten material, there will be lots and lots amount of water vapor and water in it. Apart from that, you can have different gases, like you can have carbon dioxide, carbon monoxide, sulfur dioxide, then and you can have H2S, you can have methane. There are several gases that are also associated with the eruption of a volcano. So apart from that, you can have a large amount of volcanic ash which will give you some kind of cloud or ash cloud like this. So you can have larger ash cloud, you can have smaller ash cloud depending on the explosiveness of the volcano. We will be talking about that as well. And talking about the solid materials, there could be solid parts or these solid fragments. There could be larger fragments of rock that are erupted from the volcanic cone. There could be smaller, you can say smaller particles as well. Depending on the size, they are grouped from volcanic bomb to your lapilli and tooth on the basis of the grain size of the particles, that are the solid particles that have erupted from the vent of a volcano. So whenever a volcanism is taking place, the resultant materials will be or whatever material is erupting onto the surface of earth, it is not only a liquid magma, it will contain some solid particles in it, as well as there will be huge amount of gases and ashes as well that will be related to the eruption of a volcano. There are three broadly eruptive styles of volcano based on its activity. The first one, you might have read about this in your school life as well, but just to go through it very quickly, that the first type is your active volcano. A volcano is considered potentially active if it has erupted during the last 10,000 years. And how you can recognize it? You can recognize an active volcano if some lava that we get to see in the Great Islands of Hawaii, where your continuously lava is being outpoured onto the surface of the earth. So definitely it is strictly an active volcano which is continuously outpouring some lava material on the surface of the earth. Then the other end member is your extinct volcano. An extinct volcano is one that is not expected to erupt again in the future, as its source is now depleted. The source means we are talking about the magma chamber we refer to, from which due to changes in the buoyancy, your molten material has erupted onto the surface of the earth. That magma chamber is now completely depleted. That means no molten material is present in the magma chamber, or whatever molten material was still present has now solidified. So you don't have the supply, or you don't have the source material to support the continuous volcanism. So that's how a volcano goes into extinction. But the intermediate one, which is really a tricky one, that if a volcano is in a dormant state, a volcano that is not erupting now but is considered likely to erupt in the future. So in this case, we will consider that under dormant volcanism or dormant volcano. So there is a way you can identify dormant volcanism. If in case of dormant volcanism, you will be saying that obviously the source material from where the molten supply is coming on is not depleted obviously, but it is some kind of in a resting stage. So what will happen, that only some gases will erupt through this vent or the crater of the volcano. So what will happen, that over the time, if it is goes on and on, there is a possibility that again the molten material that is present within the magma chamber beneath the volcano might again erupt due to some changes in the buoyancy again, and that is also related to its composition. We will be talking about that. So examples of active volcanoes, like the first one I have given already, the Hawaiian Islands, then Mount Etna in Italy, Mount Stromboli in Italy as well. So they are erupting almost constantly for the last 2000 years. That has been documented till now. Dormant volcano examples include Mount Kilimanjaro in Africa, in Tanzania, and also Mount Fuji in Japan. Then you can also think of extinct volcano, which has been now reported presently as completely extinct, like that of Mount Thilsen in the Oregon of USA. But always remember, an extinct volcano, what we feel that is extinct based on the different records, of your seismic records and other records that we or some geophysical record that we can gather beneath the surface of the earth, can also turn into the means based on geophysical method. If I am referring a volcano as an extinct one, in future it is also possible, due to some generation of new molten material at a new magma chamber which is further beneath the, you can say, the a present position of the magma chamber of the extinct volcano. If there is some other magma chamber that is present beneath that, or behind that, or beside that, in that case it might also supply new molten material to the earlier extinct magma chamber, and an extinct one can also become a active one due to some changes in the subsurface magma chamber. So there is a possibility always for extinct volcanoes to become dormant and finally active. Also there is a possibility of active volcanoes to become dormant over the time if the magma supply is not continuous, if the gases that are emanating from the or emanating during the active volcanoes have reduced down, or there are only a few events of some gaseous ejection. In that case also we can group, in future we can group an active volcano under dormant volcano as well. So these are the two end members, your active one and your extinct one. In between there are, you can say, different stages of dormant volcanoes as well. Now looking at the eruptive style of your active volcano, if I am thinking of an active volcano, then if the nature of the magma is basaltic in nature, then it is mostly it will have quiet eruption. The lava will flow obviously on the surface of the earth, but during the eruption of the volcano it will be relatively quiet in nature in comparison to the andesitic one, where it will be a potentially, it will be a dangerous or violent kind of eruption you might get, and you will also develop some cones. Because in case of your basaltic, when your volcanism is strictly of basaltic lava, what is happening, whenever the lava is getting poured on the surface, it is flowing. Why? Because of the presence of low viscosity and high fluidity in the basaltic magma. Again, why? Because of the very low percentage of silica in it. But on the other hand, if I take the other end member, that if I are thinking about the granitic magma, in that case the silica percentage is much higher. It is more than 75, sometimes 80% in the granitic magma. So that's why it will be extremely viscous in nature and it will be of less or very low fluidity. So in case of basaltic magma, like we were talking about, due to very less amount of silica in it, it will have very low viscosity and high fluidity. So whenever the magma or the lava is surfacing the earth, it will tend to flow and move away from the central vent, like we get to see in case of the mid-oceanic ridges, where continuously new ocean floor basalt is getting generated, and again it is getting separated from the central zone of the mid-oceanic ridge, and it is subsequently added to the rest of the ocean floor. So in case of your basaltic magmatism or basaltic lava, the eruption will be very quiet in nature. In case of andesitic, it will be potentially violent or dangerous, because it will have an intermediate viscosity and fluidity now. So because of that, it will form a cone geometry, resulting into the eruption of the andesitic lava, and with this there will be also outpouring of gases and acids along with it. But in case of a granitic magma, what is happening, that it is extremely rare but incredibly violent eruption might take place. Why? Because of the again nature of the granitic magma. It is extremely viscous, so it will take a much longer time to surface onto to the surface of the earth, or it will take a much longer time, possibly a few million years or tens of million years, to surface onto the upper part of the earth. But in that case, it will form a large dome, because like again we discussed in the time of continental drift and plate tectonics, that granitic magma doesn't want to flow. It will stick around like big blobs or large domes it might form, and finally if it gets erupted, then it will be a massacre. It will be a violent eruption in case of a granitic magma. Examples, again for basaltic magma, you can take the example of the Hawaiian Islands. For andesitic magma, you can go to any continental arc system like that of the volcanoes that are present in the Andes mountain belt, or you can also take the example of the Mount Fuji in Japan. So these are andesitic in nature, and these are generally a result, or you can say an expression of the convergent plate boundaries. And also are a very few example, but one of the example of your granitic eruption is your Yellowstone National Park in United States of America. So there you can geophysicists have reported that there are at least recorded 3 to 4 events of granitic volcanism in the Yellowstone National Park. So it means if you go to Yellowstone National Park someday, you will find wherever you stand in the Yellowstone National Park, you are actually standing on the crater of that volcano, because it is not like only a simple cone, it's a large scale, very large scale dome that is present on the surface of the earth, and beneath that there is some granitic magma which is continuously trying to surface the earth. But the reports have been there that the first the recorded events of volcanism with respect to the Yellowstone National Park happened about 2 million years ago. First, in our record, that is first, there could be other volcanism in the past as well, but in our record it is about 2 million years, followed by another granitic magmatism or volcanism at 1 million year, followed by another one at around 6 lakh years. So it is possible that again a granitic volcanism is awaiting for us in the future, and these are extremely, remember always, these are extremely violent in nature. If this kind of volcanism occur, it will lead to global massacre. So how this magma surfaces the earth? So the gases or the volatiles that are present, and mostly these are water vapor and other gases like we have mentioned. So the gas will form bubbles in the magma chamber, and the gas bubbles get bigger and begin to develop buoyancy, so that they can simply move up like this. And finally, as the gas bubbles grow enough in size to support sufficient buoyancy to rise to the surface, then only your molten magma that will be outpoured as lava on the surface of the earth. So again, if I think about the two end members, then in case of the basaltic magma, obviously the fluidity is very high, and the less amount of silica, the viscosity is very low. So in that case, what will happen, that the buoyancy to reach the surface of the earth, you need very less buoyancy, because it is having very high fluidity in it. So with very little buoyancy, you can surface the molten material from the magma chamber onto the surface of the earth, and as soon as it surfaces the earth, it will try to flow away from the main vent or the main crater. Whereas in case of the granitic magma, again due to its high viscosity, it requires much more buoyancy in comparison to that of a basaltic magma or an andesitic one. So it will take much longer time to generate that buoyancy, but if finally that buoyancy gets reached, then definitely there will be an explosive kind of violent explosive kind of eruption that will take place when the composition of the lava or magma is your granitic. Then talking about your types of volcano, so there are several types, starting with the stratovolcano, also known as your composite volcano. They are tall conical volcano characterized by steep sides and periodic explosive eruptions like this. So you can again look at this tall volcanic cone here. This is the primary vent. You have this crater. There are smaller parasitic cone also that might develop from the main vent as well, and also there will be lava flow, layers of ashes, and during its eruption there will be huge cloud of ashes as well. So the structure of a stratovolcano will be defined as it is composed of alternating layers of solidified lava flows, volcanic ash and volcanic debris, and it is typically have a central vent or crater at the summit. At the top of the conical volcano, you will have the crater. Formation, it is formed by alternating explosive eruptions and effusive eruptions which build up layers of volcanic materials over the time, and it is commonly found at convergent plate boundaries where one tectonic plate subduct beneath the other, like we have discussed. Eruption characteristic, again eruptions can be highly explosive due to the buildup of gas pressure within the magma chamber. These are again mainly andesitic in nature. The lava is andesitic in nature. The lava flows may also occur during less explosive eruptions, but they are typically more viscous than that of the sealed volcanoes. Again, for sealed volcanoes, in that case the lava is strictly basaltic in nature. So that is why they will flow less in comparison to the basaltic lava. So they will have steep cones. In case of basaltic lava, they will flow more, very fast with high fluidity. So the cone will have a gentle slope. We will see. Examples include the Mount Vesuvius, St. Helen in the USA, Mount Vesuvius in Italy, and Mount Fuji in Japan. So these are the different examples of your stratovolcano. Then you can have a cinder cone volcano. It's a type of volcano that forms when lava fragments are ejected from a volcanic vent during an eruption and accumulated around the vent to form a cone shaped hill like this. So typically they have also steep slope with a bowl shaped crater at the summit, composed mainly of loose volcanic fragments such as cinders, ash and volcanic bombs. They are formed through explosive eruptions where gas rich magma is ejected violently into the air. As the magma fragments solidified while airborne, they fall back to the ground around the vent, building up the cone over the time. Talking about the main eruption characteristics, eruptions are typically explosive due to high gas content of the magma. The eruptions are often short lived but can be very intense. Cinder cone volcanoes may exhibit strombolian or volcanian eruption styles. We will be discussing about the explosiveness of volcanoes in a bit, and examples include If cone in Canada or Paricutin in Mexico. Then you also have shield volcanoes, where, like I was mentioning, the main characteristic lava flows will be strictly your basaltic in nature, which has high fluidity, so it can flow, and the cone or the volcanic cone will, due to the high fluidity, they will develop gentle slope, or the volcanic cones will have gentle slope. Typically composed of low viscosity lava flows, like I was mentioning, basaltic in nature, formed through the repeated eruption of low viscosity lava which spread out in thin layers, gradually building up the shield core, like that of your Mauna Kea volcanism. Typically non-explosive, again we have discussed why these are non-explosive in nature, due to the low viscosity of the lava, and can experience effusive eruptions where lava pours out steadily rather than explosive events. So, you can see there is continuous eruption of lava, so you do not need large explosion to build up the momentum for a violent volcanic eruption. So, continuously your lava is outpouring on the surface of the earth. So, examples include Mauna Loa in Hawaii, that is the world largest shield volcano. There are other examples like Mauna Kea, that is also in Hawaii. Now, when your volcanoes are now, so these are the volcanoes where we can directly see on the surface of the earth, but there are also volcanism that are continuously taking place on the ocean floor, like we have discussed about the generation of new ocean floor basalt across your mid-oceanic ridges. So, mid-oceanic ridges are obviously the sites of volcanism, and they are characteristic of your divergent plate boundaries. So, there is continuous volcanism, again that is why they are not, you can say, very violent in nature, because continuously basaltic magma with low viscosity, high fluidity are getting erupted on the ocean floor, and that is making up the oceanic crust, and that is again basaltic in nature as we know it. So, apart from the mid-oceanic ridges or rift valleys, you also have some volcanic islands that are present along the continental shelf regions or on the ocean floor, or the volcanic arc sometime. So, if the volcanic arc or the volcanic island is present beneath the surface of the, you can say, the surface of the water, or the upper layer of the, or you can say it is beneath the mean sea level, then that will be obviously a seamount, and if it is simply above the mean sea level, it is referred to as your volcanic island. So, if there is a volcanic island formed as a result of magmatism, due to, not due to the presence of a mid-oceanic ridge, due to the presence of a hotspot. We will talk about hotspot in a bit, but in this first part of our discussion on volcanic activity, simply take my word as of now that hotspots are molten material that are coming deep within the earth from the core mantle boundary, means the boundary between the outer core and the mantle. Some molten material is coming up from depth and is rising onto the surface as your volcanic island. So, here you can see the volcanic island. If now the plate, like we have discussed earlier, that it is the plate that is moving, not a continental landmass. Similarly, if the ocean floor where your volcanic island is present due to some hotspot that is coming from depth, if I am moving the plate, so what will happen? This active volcano will now go into extinction, sometimes dormant as well, but mainly it will go into extinction. Some new volcano will be erupted just above the hot spot from where continuous molten material is coming up on the, or it is trying to protrude the surface of the earth. So, what will happen to this volcanic island after it is detached from its supply, or after it is detached from its source? What will happen? It will then, during the period of erosion, it will try to sink, it will means eroded, it will means lose its size and shape. Finally, means it will it be less, means it will lose its elevation, to be specific. So you can say that is your sinking island. Finally, if it is also getting eroded, the main core is also, or the main crater is also being eroded, then it will form a geomorphic feature again in the ocean, that is referred to as Guyot. Then you can have the sinking island within this barrier reefs. There are sometimes coral reefs that get developed along the circumference of the volcanic cone. Then finally again this island is completely, you can say, eroded, then you will get what is known as a lagoon or atoll. So and it will finally, if it is going beneath the mean sea level, it will be referred to as a sea mount. So these are the different stages or the fate of a volcanic island that has now gone into extinction due to its detachment from the source or the supply of the molten material. So finally a volcanic island may get transformed into a sea mount. One of the examples that I would like to talk about here, about the explosiveness or the, you can say, direct contact with the lives and livelihood of human being, then it reminds me of the best example of the dormant Vesuvius volcano and the fate of the people of Pompeii and Herculaneum, the two small towns on the, you can say, the fringe of the Vesuvius volcano. So the Romans during the settlement of the city of Pompeii or Herculaneum, they believed that this Vesuvius volcano is an extinct one. During that limited technological, means you can say technological advancement at that time, based on their assessment, they believed that this is actually, they didn't even know that there is a volcano that is sitting right at the next door of their city of your Pompeii or your Herculaneum city. So Herculaneum is a relatively smaller city near the fringe of the Vesuvius mountain, and Pompeii was a larger city in comparison to your Herculaneum. So what happened that during the Roman started living, or they settled in the cities of Pompeii and Herculaneum, that obviously Mount Vesuvius is a stratovolcano as we know it now. So on 24th of August in 179 AD, before that the last eruption of Mount Vesuvius was around your 150 BC. So after that in AD, we are now talking about 79 AD. At that time, on 24 August, what happened? Again, the Mount Vesuvius, it erupted violently and killing all the people in the cities of your Pompeii and Herculaneum. So this is a view of the Mount Vesuvius from the Pompeii. I was fortunate enough to visit this place. So from here we can have a view of the Mount Vesuvius, and due to the eruption of this stratovolcano, you can see the complete city of Pompeii and Herculaneum was completely destroyed. I will not say the structure of the city is destroyed completely, because of the high amount of ash that was released from this Vesuvius mountain or the Vesuvius volcano. It erupted and completely covered these two cities for approximately more than 4 or 5 meter thickness of ash was all over the place until late 1700s, when someone first found the existence of some city or township in the fringe of this Vesuvius mountain belt. So the first out of these two towns, the first that was hit by this ash, and we will be talking about mud flows, that is lahars, that was hit by this ash cloud and this lahars, was the city of Herculaneum. which got destroyed within a few hours of the eruption of the Vesuvius volcano, followed by about another 3-4 days. The rest of the Pompeii city also got covered within this thick sheet of ash, and they are so much thick. This ash layers were so thick that it almost preserved. You can see some cast of victims, bodies that are still preserved in the city of Pompeii. I was again fortunate enough to look at this city and also the Mount Vesuvius in person a few years back. So, the devastation that Pompeii and Herculaneum were buried under meters of volcanic ash and pumice. The ash acted as a preservative, freezing the city in time, and loss of life was. It is expected that there was more than several thousand of people were perished during this eruption of Mount Vesuvius. So, this is again a view of the other side of the city of Pompeii. Here you can see the structures, these Roman architectures you can see in this photograph as well. So, I was talking about Lahar before finishing the first part of our discussion on volcanic activity. We will be looking at the Lahar. Lahar is means it actually refers to your mud flows or the volcanic mud flows, and these volcanic mud flows are formed as a result of both your torrential rains that usually follows an event of volcanism, because huge amount of water vapor gets ejected into the atmosphere, and that subsequently it turns into torrential rains. And also if because the volcanic cones are generally they have reached an elevation, in many cases generally there is some ice, or you can say some both your ice and other particles are present, or sediments that are present on surrounding the crater as well as on the surrounding zones of the volcanic cone. So, during this torrential rains and also some lava flow that will get added along with the mud or the melt of the glacier that is already sitting on the top of a crater will finally form large scale lahars or volcanic mud flows. A lahar travels down a river in Guatemala. You can see it is kind of volcanic material, extremely thick. It is composed of several particles or sediments, as well as materials derived from the lava itself as well, and it can flow very easily because it also contains large amount of water, and it gets triggered if there is a torrential rain just after or subsequent to an eruption of a volcanism. There is the best example I can think of the destructive nature of lahars is the ghost town of Armero. It is referred to as the ghost town because the complete population here was destructed or died due to this huge amount of volcanic mud flow or lahar through this city or town of Armero in the country of Colombia in South America. So, here I would like to conclude our discussion on the first part of volcanic activity. Then we will look, and in the second part we will discuss on the different phases of volcanism as well as the explosiveness of volcanism. Thank you.